Okay, I will say that, most calculus teachers do not use the definition for this one. What they do is they derive both the derivative of sine and cosine through definition, but then they say the other functions are related to it. And what I mean by that, d dx of secant, and again, I've really never seen a teacher go through the derivation of this, but we'll do that. And what is this going to be? Well, it's d dx. You have to relate back to what you do know, which I'm going to say is really just the cosine to the minus 1 power. And can you take that guy's derivative? You can. It's going to be minus 1 cosine x to the minus 2 times derivative of cosine, which is minus sine x. And again, we have to simplify that. What do you get over there? You get sine x cosine x squared, which is cosine x times cosine x. And what do you get there? Sine over cosine's tangent of x and 1 over cosine secant. So we're expecting to get this in the end, by the way. And what I mean by that, we're expecting, after all the dust settles of using the definition, we're expecting to see this over here. We actually expect to see it. So how do we go about that? You just write definition down. And what's going to be the limit as h goes to 0, the function evaluated x plus h minus the function over h. The next thing I did was I wrote in terms of sines and cosines, and certainly it's easy doing cosines. So I put this down over here. I multiply top and bottom by the minor LCD. On bottom, you get something pretty simple. On top, you also get something pretty simple. The next thing I would do is I would expand the cosine of x plus h. All right? Now again, we're subtracting it. Let me just remind you over here, the cosine of x plus h is going to be cosine x, cosine h. Let's see, there's a plus sign there, so it's going to be minus sine x, sine h. And what are we doing? We're subtracting that. Let's make sure you understand what we said there. So I got the cosine x. I'm going to subtract this. I just did that. And when you subtract that, it's actually an addition. All right? So what am I looking for? I'm looking for those limits again. All right? So what I do is I move things around. Erase this over here. I move things around. And what I move, let's take a look at it. I split into two separate problems. I took these, whoops, sorry about that. I took these two terms here first, cosine x minus cosine x, cosine h, and then these two terms over here. All right, same denominator, two separate limits. What am I looking for? Those things I know about. All right, so what I do is I factored out a cosine x on top, and I associated the h with the factor that remains, which is 1 minus cosine of h. What goes on bottom over here, the other factor, which is cosine x plus h cosine x. Same for the second limit. I associate this over here. I get this. I want to point out, it should be recognizable. What do you mean by that? This limit here, you should recognize it, and this limit over here, you should recognize it. And we did that in the beginning, and those two limits are over there, all right? What do we know about that? Again, when I said they're similar limits, like, for example, cosine h minus 1 over h is really the same thing as saying 1 minus cosine h over h, really the same limit. All right, so what do you get over there? 0 times sine x, whoops. I'm sorry. You get 0 times this term over here. That disappears, and this is 1 times this term over here, all right? But what's the limit of that guy over there? Well, it's going to be sine x over cosine x plus times cosine x. We get this over here. What does that reduce to? This thing over here. Thank you.